I'm Ross Bagurtis, and you're watching Introduction to Network Protocols. Now, what I want to talk about in this video is how we actually using network protocols to do all of the tasks that we do on a day-to-day basis when we're using the public internet or using our PC in general. And if we take a look at network protocols, there is a literal sea of protocols out there. And I've put a few of them out here, and we're going to be covering all of these protocols at some level throughout this course. Some we're going to spend much more time on, others we're going to spend much less time on. But ultimately, a network protocol is nothing more than a set of rules. So a set of rules that an application can then use in order to transfer data from one device to a different device. And the protocol we use is going to be dependent upon the data that we have to transfer. We often see a lot of overlap here. However, each one of these protocols was written for a very specific purpose. And as we make progress through this course, we are going to see how these network protocols are actually implemented. Let's take a look at some of these network protocols. If we want to surf the web, we are automatically going to be using two protocols, HTTP and HTTPS. HTTP and HTTPS stand for Hypertext Transfer Protocol, and Hypertext Transfer Protocol Secure. So HTTPS is actually encrypted. So we actually encrypt the data before we send it between the two devices. And we use this oftentimes in banks for bank transactions when we're transferring email and other applications where we have sensitive information that we don't want to have others spying on. HTTP is unencrypted. It's sent between the two devices in complete clear text. So when we're using HTTP, other individuals on the internet have the possibility of listening to your conversation if you're using an unencrypted protocol like HTTP. When we transfer files, oftentimes we'll use protocols that are file transfer protocols. And here we have kind of a suite of three file transfer protocols: FTP, SFTP, and TFTP. So we have file transfer protocol, secure file transfer protocol, and trivial file transfer protocol. We use trivial file transfer protocol for transferring very small documents, and we often use it to put data on and off our network devices. FTP and TFTP are both unencrypted and send their data in clear text, which means that other people on the network can sniff your traffic and listen to your conversation and read your data. SFTP, secure FTP, is encrypted, which means that it's much more challenging for an individual sniffing the network to actually see the data you're transferring. Now, email. Email is a big one because email was around long before HTTP was. So we were actually using email before we were using web browsers. Web browsers didn't come out until 1992 or 93. That's when University of Illinois Champaign-Urbana came out with Mosaic, which eventually turned into Mozilla, which I believe now is kind of morphed into Firefox. So that's been in the world for 20 years now, or email's been around for quite a bit longer. So the protocols we use for email today oftentimes are just browsing to a website like gmail.com or outlook.com or yahoo.com. And we would do that over HTTPS. So we actually just open a web browser and go to a website to get our email. However, we can still use these three protocols actually to send and receive email. POP3, Post Office Protocol, IMAP, Internet Message Access Protocol, and SMTP, Simple Mail Transfer Protocol. We use SMTP actually to send mail from our device out to the internet. POP and IMAP are used to retrieve mail messages from the internet down to our device. Remote device access. There's really three big protocols we use here. Telnet and SSH are used for command line access to devices. Telnet is the unencrypted version of SSH. So if we're using Telnet, we can actually sniff the network and see usernames and passwords being transferred over the Telnet protocol because it is all sent in clear text. Very dangerous. SSH, on the other hand, is the encrypted version of Telnet. It's much, much harder to access the data. As a matter of fact, I do not believe that SSH encryption has been cracked at all yet. I believe that there are some theoretical ideas about how to crack it, but I don't believe that anyone, less maybe the NSA, has actually cracked SSH encryption. So we can use that actually to use a text-based interface to our device. And later on in the course, we're going to be using Telnet and SSH extensively to configure our routers and switches throughout the rest of this course. A remote desktop connection is another one. We use remote desktop connection in a Microsoft world to access the desktops of devices that aren't near us. So I have remote desktop connection set up on one of my devices here, and I'll actually show you how that works. In modern days, we have other remote device access. We can actually do it through the web, through utilities like LogMeIn or TeamViewer. There's some other applications out there as well that allow you to build a remote connection to your device, like VNC, Virtual Network Connection, which will give you remote desktop access to your device. Last, we have a very, very, very important, if not the most important protocol on the internet, and that is DNS, Domain Name Service. And Domain Name Service is the literal white pages of the internet. If we think about Google, Google kind of replaced the yellow pages, right? We type in a category of what we're looking for, and it spits out information related to that category or those keywords. So it kind of behaved like the yellow pages as far as Google goes. DNS is the literal white pages because every single domain name that we go to, google.com, yahoo.com, trainsignal.com, you name it, we cannot actually send data to that website unless we know its IP address. Now remember, the IP address is that logical identifier we use to get data from our device to some other device on the network, much in the same way that we use the post office to send letters to friends, family, and businesses. We use the business that we're sending our letter to, we use their logical address on the letter that the post office set up so that we can send our message to them. DNS is the mechanism to take some domain name and transfer it to the logical IP address. So instead of babbling on more about how these protocols work, let's take a look at a couple things about, one, how many of these protocols get adopted and ratified, and then two, let's go take a look and see how they work. So let's do some demonstration. So first off, I will open a web browser. My preferred web browser today is Google Chrome. The reason it is one of the most standards-based web browsers available right now, it's free. There appears to be a massive browser war going on. You can choose between Internet Explorer, Firefox, Safari, or Chrome are the big players out there. Chrome I have found to be the most stable, to give the most consistent results, and also to behave with protocols as accurately as possible. The other browsers, it's not that they don't work or that you can't use them, you just may expect different results. For the purposes of this course, I do recommend that you download Google Chrome and use it for the exercises here. However, I'm not opposed if you use other browsers, just don't expect the same exact results. So first off, these protocols that we're using, specifically the one to access the web via a browser, is HTTP. And we oftentimes see this in the address bar when we browse to websites. Now, all of these protocols that we're looking at, the first website I want to actually look at is I want to do a search for the site that hosts all of these protocols. Now, in order to get these protocols that we use on the network ratified and available for people to implement, what happened is we set up something called the Internet Engineering Task Force, or IETF. And I'm just going to do a Google search for IETF so that we can load up their website. So IETF, Internet Engineering Task Force, and here's their website. Now in the IETF, what they do is they host something called RFCs. And if we look over here on the leftmost side of the page, we say RFC pages. So we'll click on that link. And what an RFC is a request for comments. Now, what happened in the early days of the internet is that the engineers needed an open way to communicate with each other about how the protocols they were going to use to build the internet were going to work. So they built this database called Request for Comments, and now we can search Request for Comments for these different types of protocols. It looks like on here I can't search for HTTPF. Let's see. Let me give this a try. We're going to search for HTTP and see what we come up with. And while that searches, what we should hopefully find is that HTTP is going to be associated with an RFC number. All right, and internet. This is not the time to give me problems. Let's try this again. We'll stop that and search. Well, it certainly doesn't like that. So, what I'll do instead is I'm just going to search up in Google RFC HTTP, and what that should do is it should pull me to the HTTP protocol. If we look at our Google results, you do see that I am at the ietf.org website, so I am still going to be at IETF. Once I click on that link, it brings me to one of the HTTP protocols. In here, it lists all the details of how Hypertext Transfer Protocol should work. And it's quite long. And unless you are an application developer or you are a hardcore network troubleshooter, very rarely do you have to come back to the RFC to review the content of actually how it works. And the reason for this is that web browsers like Google Chrome actually take the RFC that's written and they implement the rules of the RFC into their application. This way, we have a standard hypertext transfer protocol system that we can then implement in multiple different applications. In this case, Google Chrome. Internet Explorer has its own implementation of HTTP. So does Safari, so does Firefox, and any Opera and any other browser you want to use out there. But these RFCs are out here for nearly every single internet protocol available, including HTTP. And we can look them up and examine them as we need to. This is pretty boring though, so let's take a look at how these protocols work. Let's look at some examples. Some of these you've seen before. Most of us have used a web browser before. As a matter of fact, in order to watch this video, you have to be able to use a web browser to browse to trainsignal.com. So let's do that. We're going to use my web browser here, and I'll go to http://trainsignal.com. Now I'm using Hypertext Transfer Protocol to move the data, and the website I'm going to is TrainSignal. What will happen is then the website, of course, displays on my screen. I can choose to go to a secure website as well. As a matter of fact, when we log in here, it brings us to a secure website. And the reason for this is that in order to get the base website up, it's just pictures. It's a picture of this computer showing the VMware training. There's really no critical information on here. So if we look up in our address bar, we'll see that it's kind of blank and plain. Once we click on the login link though, our browser up here changes, and now we have this green bar here with a little lock in it. That means that it is secure. We see that our protocol type changed from HTTP to HTTPS. Now what this means when we have this green bar and we're using HTTPS, it means that we are now encrypting our session. That way when we type in our email address and password here, and we hit login, it'll send our email address and password over the public internet in an encrypted form. That way others can't snoop in and read your email address and password to log into the site. It's an added measure of security to protect your account information. This is very important in data networking because we really want to send as little information as possible out onto the public internet that isn't encrypted, especially private information like usernames and passwords. So this is the basics of HTTP and HTTPS. Let's take a look at the next one we talked about, and that was FTP. Now we have lots of ways of accessing FTP. FTP protocol is actually built into the browser itself. So many browsers support FTP, and the big ones do. Internet Explorer, Safari, Chrome, and Firefox. All of these support FTP. So we can browse to an FTP site here within the browser. We can also use the command prompt. Now in data networking and data network troubleshooting, we use the command prompt a lot. And in order to access the command prompt, we always click on the Start button and then type CMD. And this will launch a command prompt. And now from here we can type commands to actually launch applications and utilities to give us information, to connect to other servers and whatnot. From here, I can actually use the FTP protocol and say FTP to my FTP server, which is at 10.128.50.104. Now I just set up an FTP server on my local network. You can do the same thing by downloading an application called FileZilla Server. It's freely available, open source community, very excellent application. So what I'm going to do here is just type FTP and then the IP address of my FTP server, which I've pre-set up. And what will happen is I will actually connect to the server. And if you look here, it's asking me now for a username. Now, since I'm using FTP, this is sent unencrypted. So my username is sent clear text over my network connection here. I'm not too concerned about it because I don't have any critical data on here. 1. 2, I'm not sending it over the public internet. And 3, it's for a demonstration, so this isn't a big deal. However, if I were using this in a production environment, I would definitely need to secure my FTP transaction so that other people couldn't snoop in and hear what I'm transferring across the link. So let's log in. My username is Ross, my password, and now I am logged on. And it brings me to this prompt that says FTP. Well, if I would like to see what files are available on my FTP server, I can type dir, and that will give me a directory of files. And you can see here there's a file on the server called tsbackground.png. And I can actually download that file from my FTP server and put it on my local machine. Let's give that a try. So if I want to retrieve this file and download it to my workstation, what I can do is I can get a file. And when I type get, it's going to say, what remote file do you want? And I type in tsbackground.png. It's going to say, where do you want to save it? Well, I want to put it on my desktop. And I know my desktop is at c:\users/ross/desktop. And I will call that file tsbackground.png. And I hit OK. And it transfers the file, and if you notice, that file then popped up on my desktop here. If I double click on it, you'll see this is just a train signal background for your desktop. So I downloaded this train signal file from my FTP server to my local workstation using file transfer protocol. Once again, we can use FTP in a multitude of ways. There's lots of different applications we can actually use to use FTP. Using it through the command prompt is only one mechanism. Let's end my session. Quit, maybe it is. Sometimes I don't always remember the commands. Quit, it is. It says goodbye, and we're done. We're no longer connected to our FTP server. How will secure FTP and trivial file transfer protocol, TFTP, how will those differ from this? They behave nearly identically to FTP. It's merely a different mechanism being used to transfer the data. One is encrypted, and TFTP uses a different protocol to transfer data, and we're going to study that in much more detail in a future video when we talk about TCP and UDP. So let's continue on. Let's take a look at email. Now, most of us today access our email either through a web browser like this one. We use Google Chrome here for accessing email, like Gmail. If you have a Gmail account, you'll log into the website here. You might go to mail.com yahoo.com, and it brings you to a different site. And notice that all these sites are using HTTPS. And the reason they are is they want to encrypt your username and password so that somebody else can't get it. If they didn't do this, what we'd find is a bunch of hackers out there would collect your usernames and passwords for your email account, and then they'll use that information to actually send spam from your email account, which reduces the trustworthiness of your email account, which then causes problems. It makes your friends upset, blah, 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 blah. So we can go to these different sites and access our email via a web browser. Now this is distinct from the protocols that we actually used in order to collect email previous to web browser email. And what we would do for that is we actually use an application, some type of mail client. Now we are kind of used to this a little bit if you have a smartphone. If you have a smartphone, you have a mail client on your smartphone. That mail client is used to download email from an email server to your phone, and then when you want to send a message, you send a message from the client on your phone up to the email server. We can do this on a workstation as well by using a program like Outlook. And if I open up Outlook, there's other freely available mail applications out there as well, like Thunderbird. At any rate, right now I just have a base Outlook configuration, and Outlook, the fact that I'm using Outlook here is really not important. What I want to show you is how to set up an account and where we see these protocols for POP and IMAP and SMTP show up. So if we click on File and Add Account, what we're going to find today is that most email accounts auto-configure themselves. So our application developers have gotten really good at allowing email programs to auto-configure, and this is outstanding for our end users. We don't need to know a lot about protocols then to make email work. However, back in the day, now I've been using the internet since the late 80s, and in the late 80s web browsers weren't around yet. You connected either to an internet service provider over a dial-up modem, or you connected to something called a bulletin board service, which was usually just an independent nerd who had a modem or a pool of modems, and you could connect to that bulletin board service. And that's how you downloaded pictures and chatted with other people and things like that. The bulletin board service oftentimes had a mail server set up, so you could use their email services to connect to other people on the public internet. However, if we look at our add account settings when we set it up manually, it talks about Microsoft Exchange and Outlook with ActiveSync and all these weird names. At the bottom here, the last one, we have POP or IMAP. Now these are the oldest protocols out there on the internet for email. If we click next, we're going to see that we can put in our name and our email address, and then we can choose the account type. Is it a POP3 email, Post Office Protocol, or is it IMAP? And essentially what the system is asking us is, are we downloading from our server using the IMAP protocol or POP? We'll give it the server name for our incoming server, and then we have to specify an outgoing server, which is our SMTP server. And here our SMTP server will be the outbound mail, so whatever's coming when we want to send an email from our device out to the internet to our buddy, we use SMTP to do that, and we specifically enter that information here, as well as our login information and other settings here. What I'm getting at is, prior to all this auto configuration, we had to actually choose what protocol we would use, and we'd have to have information from our internet service provider or email provider about how to set that up. Now most of that is done for us automatically. If you're using an iPhone or a Windows phone and you have a Gmail account, when you set up your phone to use the mail application on for those devices, it's actually going to use IMAP to transfer the data between your phone and the server. Typically, though, this is automatically configured and transparent to the end user. However, as a future network nerd, you're definitely going to need to know what IMAP is doing there, and IMAP is the protocol that we're using to send email to the internet. SMTP is our outbound mail server, going out to the internet. I'm going to cancel out of this and show you two other features. And those are the remote connectivity, so remote access to other devices. First, I'm going to show you the pretty one, which is remote desktop connection. So let's build a remote desktop connection to my FTP server. To do that, I'm going to click on my start orb down there and look for remote desktop connection and open that up. Now I've already have the IP address populated in here. I'm going to connect to 10.128.50.104. This is my FTP server. And what will happen is going to ask me to log in. And now I have a screenshot of my other workstation. Let me scroll down here and you can see that I have a start bar and a start menu, and I can click and open up different files. So this here is my FTP server. As a matter of fact, the log is up here for my FTP server. If you look through this, you'll see that right here I transferred a file called tsbackground.png to my desktop, and the transfer is okay, and then I ended. So this is the log of what I did with the FTP connection. So this is remote desktop connection, and if we set this up properly, you can access pretty much any desktop anywhere. There's multiple versions of this protocol. Remote desktop connection is Microsoft's version. There's also virtual network computing, VNC, which is an open source product out there that does something very similar to this. I close out this. Now, not every device has a graphical user interface, and we're going to learn this very quickly as we progress through this course, as when we connect to a Cisco router or a Cisco switch, those devices typically do not have a graphical user interface. And even if they do, we often don't want to use them because they make a simple task ridiculously complex. So what we do for that is we either use Telnet or SSH. And as I said earlier, Telnet is the unencrypted version of the protocol. SSH is the encrypted version, meaning SSH sends the data encrypted and securely over a network connection. Telnet sends it in complete clear text. So if I open up this application called PuTTY, what PuTTY is an open source, freely developed utility for Windows to do Telnet and SSH connections, as well as serial connections, and we'll talk about those once we get into router configuration. So let's look at Telnet first. So Telnet and SSH look identical. One is encrypted, one isn't. Let me connect to a router, and I have a router at 192.168.10.1. And if I connect to that, what'll happen is it'll pop up a new text-based interface for me to type in a username and password. My username is admin. And now it brings me to the command prompt of my router. And now I can do different things. I can show run and see information on my device. So this is a mechanism for me to connect to a different device than my workstation using a command line interface, or CLI. And this is, like I said, this is going to be incredibly useful later on when we are configuring our routers and switches. We'll need this text-based interface to do that. So let me disconnect from my ACL router here and come back to the home screen. So last, what I'd like to take a look at is DNS. Now, DNS, Domain Name Service, like I said earlier, is the white pages of the internet, is what translates a domain name into an IP address that we can use to communicate. Now, there's a utility we can use in the command prompt that will allow us to actually take a look at resolving domain names into an IP address. In order to get there, we need to open the command prompt. Now, to open the command prompt, I clicked on the start orb, typed CMD, and then clicked on the CMD application. So here's my window. I can use the application called now NSLookup. So if I type NSLookup and type enter, what it will do is it will connect me to my DNS server, and now I can look up domain names and translate them into IP addresses. So let's start with something that we know first. We'll do www.trainsignal.com. If you press enter, it will then provide us answers. and I'm going to highlight some of this. So, trainsignal.com can be resolved to either 184, 106, 104.28, 50.57.186.202, or 50.57.186.253. Now, why are there 3 IP addresses here for one website? Well, there could be lots of reasons for this. Most often, we have multiple IP addresses for every single URL so that the users on the internet always have access to a device. This way, if the first IP address is busy for some reason or that server is overloaded, we can then connect to the second IP address and use that resource, or the third IP address. So these IP addresses there's 3 of them, we may load balance between the 3 IP addresses for redundancy and availability. Not all websites behave like this. Trainsignal.com has 3 IP addresses. If we go to a smaller website like Veronica's Plant Nursery, let's type that in, Veronica, and I can't spell very well, so hopefully I get this right. So if you do veronicasplantnursery.com, it will look that up and it translates that into a single IP address, 50.87.144.250. Does this mean there's no load balancing going on? Not necessarily. We don't know from this end. All it means is that veronicasplantnursery.com only has one IP address. Well, what's another way to look at this? Another way to look at this is kind of like maybe your telephone number. If we're comparing DNS to the white pages, myself, Ross Pagurtis, I actually have 2 different phone numbers. I have a cell phone number and I have a Google Voice phone number, so I have a virtual phone number out on the web. I actually have a third phone number, and that's my work phone number. So you can reach me at either my Google Voice phone number, my cell phone number, or my work phone number. They all come to me. Same thing here. The 3 IP addresses we have listed for trainsignal.com, all those IP addresses are associated directly with TrainSignal, and we can reach trainsignal.com on any one of those IP addresses. If we look at a more sophisticated and larger site like Google, we're going to find out that Google, in this case right now, has 1, 2, 3, 4, 5 different IP addresses. I've seen Google resolve with many, many, many more IP addresses than 5. As a matter of fact, I said Google was more sophisticated than these other sites, and if you look, I'll highlight this here, there's this goofy number at the beginning. And that goofy number at the beginning is the IP version 6 address. The IP addresses at the bottom here are IP version 4. And in the next 5, 6, 7 years, maybe sooner than that, we're actually going to be making a huge migration from IP version 4 to IP version 6. So it's highly likely, if you're studying the CCNA today, that at some point in your career, if you continue in networking, you will definitely be either setting up an IP version 6 network, or you will have to manage an IP version 6 network. The good news is, in ICND 2, we actually cover IP version 6 in detail and show you how to set up some devices, and you can actually see how it works. So we're actually going to get you introduced to the topic in a later video. For the time being, though, now you can clearly see that we can resolve the host name, google.com, trainsignal.com, veronicasplantnursery.com. We can convert those all into IP addresses using DNS. We use the NSLOOKUP utility if we want to see the IP address that's happening in the background. When we open up a web browser like Chrome and we go to www.google.com, we're actually doing that domain name service, the DNS resolution of google.com into an IP address. That happens automatically in order to allow the website to come up. But we are making use of this utility DNS to resolve our host names that we type in into IP addresses. This makes surfing the web so much more pleasant because we don't have to type in this number with 4 values in it, and later on we won't have to type in this number that could have a whole ton of numbers in it. This wraps up the introduction to network protocols. Really what I wanted to achieve is give you a basic understanding that protocols exist and they govern the communication between 2 devices transferring certain types of data. And the protocol we use to transfer that data is going to be dependent upon the data itself and the mechanisms that we have in place in order to access it. So HTTP for websites, FTP for transferring files, POP3 and IMAP for email, Telnet SSH, remote desktop connection for remote connections. As we progress through the course, we're going to learn more and more and more about network protocols and how they operate, and we're actually going to begin to categorize them into the OSI model. With that, I look forward to learning with you in future train signal videos.